All right, so in this video, I'll be going over page 14 of the notes packet. This is where we're rationalizing the denominator. So in math, it's standard to write all your answers with all of your irrational numbers in the numerator. So for example, these ones are okay because their denominators are rational, right? 3, 10, 5. If you don't know what an irrational number is, it's just a number that goes on forever without repeating. So pi, or the number e, kind of quintessential examples, or any radical that cannot be simplified fully. So these ones down here would not be okay because they have an irrational number in the denominator. So where our goal is to get the irrational number out of the denominator. And we can do this we're going to do this in two different cases. We're going to do this in the monomial case, where the denominator is just a number. We're going to do this in the binomial case, where we have something being added or subtracted. So we have two terms in the denominator. So in example 1, we can multiply the numerator and the denominator by the radical on the bottom. So here we would multiply by root 2 over root 2. The numerator is going to become 6 times the square root of 2. And in the denominator, we know that the square root of 2 times the square root of 2, well, that's just 2. And now that we have 6 and 2, we can simplify that to be 3 root 2. So see how this is a lot nicer to look at than this, and we know that they're equal because we multiplied it by something equal to 1. Right, and if we do the same thing over here, we can get root 3 over root 3. Root 6 times root 3, we can write that root 18. 2 times root 3 times root 3, well, root 3 times root 3 is going to be 3, times a 2 is going to be 6. And we want to make sure we're simplifying all the way, so this root 18, we might recognize it as the square root of 9 times the square root of 2, which means that we can write it 3 times the square root of 2 over 6, which means we can simplify it to just be the square root of 2 over 2. Right? So that's kind of the goal when we're rationalizing denominators. We have some practice questions down here. So we can write that as root 7 over root 7. It's going to be root 7 over root 7 times root 7 is just 7, so root 7 over 7. Here we're going to multiply by root 11 over root 11. It's going to give us 5 times the square root of 11 over 11. Or here, we're going to multiply by root 2 over root 2. It's going to give us 5 root 12 over 2. Remember, root 12, we can simplify that further. So root 12 is the same as saying root 4 times root 3, which is 2 root 3. So we're going to have 3 times 2 root 3 over 2. And cancel the 2's. And sorry, that should be a 5, not a 3. So 5 there, 5 there. Cancel the 2's, and the result is just 5 root 3. All right, and for this one over here, we're going to multiply by root 6 over root 6. We can get 7 root 72 over 6 times root 6 times root 6. Well, root 6 times root 6 is 6, times another 6 is going to be 36. And the square root of 72, we can rewrite that the square root of 36 times the square root of 2, or 6 root 2. It's going to be 7 times 6 square roots of 2, all over 36. We can cancel the 6 there, cancel the 6 there, and so our final answer is 7 square roots of 2 over 6. That's the end of page 14.